Welcome to this special Armada podcast produced in association with Silvus Technologies. I'm Tom Withington, editor of Armada's military communications newsletter and webpage. As the electromagnetic battle space rapidly evolves, the stakes for robust and resilient tactical communications across mission-critical applications have never been higher. As near-peer adversaries continue to develop and deploy advanced electronic warfare capabilities, traditional radio systems have struggled to adapt to these new and unique operational challenges. In the future fight, the warfighter's ability to operate in congested and contested electromagnetic environments and persist in the presence of jamming and interference has emerged as a critical need. Several technologies exist to meet these goals, including mobile ad hoc networking radios and self-forming, self-healing mesh networks providing data connectivity at the tactical edge. In addition, the US military's Joint All-Domain Command and Control Strategy, known as JADC2, empowers Joint Force commanders with the capabilities they need to connect sensors to shooters across all warfighting domains and throughout the electromagnetic spectrum across the modern battlefield, regardless of where it may be. In this podcast, we chat to Jimi Henderson of Silvus Technologies to examine the challenges of establishing and using tactical communications in congested and contested environments, highlighting the security, speed, reliability, and resiliency needed to achieve spectrum dominance. Jimmy, it's great to have you with us.
Always great to speak with you, Thomas. Thanks for having me.
Department of Defense modernization programs have a common strategic priority to enable JADC2 by connecting sensors to shooters across all warfighting domains and throughout the electromagnetic spectrum. How do tactical communications networks play into and support this strategic vision?
As you've already stated, Joint All-Domain Command and Control aims to connect all assets across all domains. And when you're doing this in an uncontested environment, a lot of times you have access to fixed infrastructure, whether it be cellular networks, whether it be strategic networks that you've in placed. Those networks provide a high degree of reliability, predictable coverage. But when you're operating on foreign soil, you don't always have access to these networks, or you can't trust or rely on them. So with tactical networks at the tactical edge, we rely on different assets, and those include an array of tools to include SATCOM, satellite communications, often used for first mile, beyond line of sight connectivity. Great tool for certain jobs, but in some cases, they're prohibitive in terms of their size, the bandwidth they can support, their cost. Sometimes the latency can be high. You can't rely on SATCOM due to adversarial jamming. And also certain SATCOM systems don't support mobility. So as warfare continues to shift towards an on-the-move capability, SATCOM in some cases will be prohibitive. So MAN-A or mobile ad hoc networks really step in to fill a critical gap in this regard. Mobile ad hoc networks, such as those provided by Silvus Technologies, they provide a very small size, portable solution that the soldier can carry that can be mounted on drones, robots, vehicles, etc. They work on the move, so they provide that mobility that you might be lacking with SATCOM. They also provide dedicated bandwidth on your own frequencies, so you're not competing for that bandwidth with other users. They typically have much lower latency as well, and a lot of the modern systems, such as what Silvus is providing, provide some resilience against jamming and interference. So I guess to sum it all up, the optimal tactical network would be a system of systems which combine and blend all of these tools seamlessly in a way that provides redundancy and resilience.
Why is the ability of tactical communications networks to operate in contested environments an urgent need for the DoD? And how have these challenges evolved as connectivity has become a critical aspect of warfighting?
Modern warfare relies heavily on interconnected systems. We talked about drones. We see a lot, especially in Ukraine. We're seeing the collaboration between unmanned ISR assets and joint fires. So using the ISR obtained from a drone to provide targeting for precision munitions. While this increases situational awareness and decision-making, it also presents new vulnerabilities adversaries are going to seek to exploit. Specifically, adversaries are employing strategies to disrupt and deny our communications capabilities. So this has turned the electromagnetic spectrum sort of into a battleground and presents a significant challenge for communications. And as the battlefield continues to evolve, adversaries' jamming capabilities, adversaries' SIGINT capabilities will continue to evolve as well. And we're going to need to stay one step ahead by providing resilient resilient communication solutions that can both avoid detection and also mitigate jamming and interference.
What are the biggest challenges of establishing and maintaining these networks in contested environments?
So adversaries' jamming capabilities might attempt to exploit different vulnerabilities at different layers in the OSI model of your waveform stack. One of the unique attributes of Silvus's software-defined radios is that we built our waveform from the ground up. And as such, we've been able to fine-tune and optimize each layer of the stack to patch up those vulnerabilities and to make sure that we're hardened against all sorts of attacks that the adversary might bring. So this makes us a bit different from some other products on the market. It allows us to implement more advanced protection such as beam forming, beam nulling, and some other more nuanced capabilities at the physical layer that would protect our waveform from advanced jamming.
What are some of the latest advances in tactical communications, low probability of interception and detection waveform technology, and resiliency techniques that allow secure and protected communications in contested environments?
We look at LPI, LPD, jammer resilience as a multi-tiered problem. It's a problem that requires different tools, and you'll apply those tools at different times depending on what sort of threats you're up against. LPD is king. We want to avoid detection at all costs. So we have multiple layers of our protection that are intended to provide lower probability of detection. The first layer is a power control algorithm. We call it MAN-PC or MAN-A power control. MAN-PC reduces the transmit power of each radio in the network to the minimum amount necessary to maintain network connectivity. And as channel conditions change, the radios will dynamically adapt their transmit power in response to that. So in the simplest example, you might have a UAV launching from a ground station. When that UAV is in close proximity to the ground station, it's able to whisper. It's able to get its signal across with a very low transmit power. As it gets farther and farther away from the ground station, it'll gradually and gracefully ratchet up its power as needed to maintain the link. We also have on the anti-jam side or the jammer avoidance side, we have an interference avoidance capability that allows us to continually monitor multiple channels across the band or the bands of operations that the radios support. In the event any source of interference comes into our current channel of operation, the radios will gracefully and seamlessly step off to the next clearest channel to avoid that interference. And we'll continue to do so at an operational tempo as needed. The last feature that I'll talk about here is a form of interference cancellation based on eigenbeam nulling. We call it MAN-A interference cancellation or MAN-IC. And what we do is we take a sample of that unwanted interference. We characterize the spatial profile of that interference, and then we apply a null in the digital domain to that interference, which allows us to effectively strip the interference from our signal, providing us with a clearer channel. You can sort of think of it similar to how you think of noise canceling headphones. It's a total game changer. It's providing an asymmetric advantage for our warfighters and our allies on the battlefield. The results are quite remarkable.
How does the Spectrum Dominance Initiative play into both the strategy for and practical applications of mobile networks?
For years, Silvus engineers have really established a reputation for delivering superior radio performance. So they've been working tirelessly to squeeze every megabit per second, every tenth of a dB out of the radios. And I think you can see the results of that in the field, and that's really a testament to the hard work that they put into optimizing the radio. As we move forward into contested battle space, and with our Spectrum Dominance package, our aim is to deliver that same level of optimality to our customers, even in those cases where it's necessary to operate covertly, and even in those cases where you might be subjected to electronic attack.
How are uninhabited platforms playing a role in overcoming these network challenges?
Unmanned systems are being viewed as a low-cost, low-risk force multiplier on the battlefield, which provides us with an asymmetric advantage. Historically, you look back, UAVs in many cases were used to provide ISR to guide fires or to provide intelligence or situational awareness on the battlefield. More recently, we're seeing a shift towards the use of UAVs for other use cases to include loitering munitions, wingmen that will fly alongside your aircraft to provide air support, and we're also seeing them be used for air-launched effects. So UAVs being launched from an airborne platform to provide either ISR or loitering munition capability, extending the capabilities of those manned aircraft. On the sea, we're also seeing unmanned surface vehicles gathering momentum. You have swarming fleets that are being used to patrol critical waterways. In the next few decades, the U.S. Navy aims to have up to 40% of its fleet be unmanned So you're seeing a very large shift there as well. So in any great power conflict in the future, our adversaries are going to seek to disrupt our ability to communicate with these assets in an attempt to level the playing field. Also, many military strategists are advocating for large volumes of low-cost attributable systems versus the legacy approach of having a smaller number of larger, more costly platforms. Quantity is quality, so to speak. So the goal being to overwhelm and disorient our adversaries. So it is critical that our tactical edge communications networks are able to avoid, and mitigate adversarial SIGINT and electronic attack. And it's also crucial for these networks to scale up to the large networks that'll be required for the future fight.
Before we wrap up, what else should our listeners know about network challenges in contested environments? What is on the horizon that will advance spectrum dominance capabilities?
With so many tools at your disposal, the next big challenge will be deciding which tool to use at what time. We look at that as the next big opportunity for us to add value and enhance our products. So we are moving forward with the implementation of machine learning and automation to create a truly cognitive radio, a radio that takes into account the threat environment, classifies the threats that may be out there, that takes into account the operational environment and also the user's objectives, and then applies the right tools at the right time or the right combination of tools at the right time in response to those inputs.
Jimmy, great to chat as always.
Thanks very much, Thomas.
If you'd like to learn more, why not visit Silvus Technologies' website at silvustechnologies.com. Thanks very much for listening.